Hanji class, good morning. Today we are going to discuss and demonstrate the Ohm's law. Now we all know that Ohm's law is a very basic law of electricity in which we have studied that voltage is directly proportional to I. Today in this experiment session we will be demonstrating that how this Ohm's law will be verified physically. We are not going to prove with any kit or any other physical material, we will be just demonstrating it by a very well-known example and a very well-known demonstrative idea by which we can implement it at home also. So, first of all, we will be studying that what is basically Ohm's law and what are the basic parameters of which it is comprising. So, first of all, we have the voltage, we have the current, and we have the resistance. These are the three main components by which we can verify the Ohm's law. Now, resistance is what? Resistance is the proportionality constant over here. Now, what is voltage? Voltage is the potential which is being provided. It is not, it is immobile. Voltage is always immobile, it is stationary, and it is the potential which is being provided to the two conducting mediums. And then we have the current. Current is the flow of electrons, that is, it is a motion. Whenever we talk about any motion of flow of electrons or flow of electricity, we talk about the current. Then we have the resistance. Resistance is the hindrance or the obstruction which is being provided to the flow of current. Now, taking all of these three parameters, we have derived or we have found out a formula using the Ohm's law which states that V is directly proportional to I. That means voltage is directly proportional to the current. That means with the increase of the voltage, we will increase the amount of current also. And V is equal to I into R. That means V is equal to IR means that R is a proportionality constant over here. Now we will be demonstrating this, that how we can actually demonstrate this example. For this I have taken this glass of water, this is full of water, and this is a disposable glass. This is actually, while visualizing this in terms of an Ohm's law, what can you visualize out of it? This water is actually a kind of a potential. It is not moving, it is stable. It is stationary, it is the potential. You can relate it to the potential. आप इस ग्लास के अंदर जो पानी है इसको पोटेंशियल से रिलेट कर सकते हैं या फिर वोल्टेज से रिलेट कर सकते हैं, बिकॉज ये जो पानी है ये मूव नहीं कर रहा, ये कांस्टेंट है, ये स्टेगनेंट है एट वन क्वांटिटी. अब अगर इसके अंदर मैं छोटा सा होल बनाता हूँ, जस्ट क्रिएट सम होल ओवर हियर, तो इसके अंदर छोटा सा होल बनाता हूँ. Okay class, now you can see I have made a small hole over here. There is a whole small piercing over here and the glass of water is decreasing. The height of this water has been decreased and the water is flowing out of this hole. You can see it very well. Now, can you relate it? What is this hole symbolizing us? This is the amount of your resistance. This hole is actually a resistance which is being provided. The wider the length of the hole, if I will widen it up, what will happen? The amount of current will or amount of flow of water will increase. The amount of flowing of water will increase out of this bucket of or glass of water. That means the resistance has been reduced over here. If the size of this hole has been decreased, if I decrease the size of this hole, what will happen is the amount of resistance has been increased and there will be less amount of water which is coming out of it. That means V is directly proportional to I. Voltage is directly proportional to I, but it is not directly proportional to resistance. I is inversely proportional to the amount of resistance. If the amount of resistance is increasing, that means the size of this glass of water or the size of this hole which is being provided over here is decreased. That means the amount of flow of water is decreased. So if we widen it up, that means the amount of flow of water will increase, the amount of current is increasing and resistance is decreasing. This is a very small demonstration for this verification of this Ohm's law. For this you can use a small tap of water also, the tap of water which we are using at our homes also. We are used knobbing it up. आपने क्या करना है, अब आपने अपनी कॉपी के ऊपर, मेटल कॉपी के ऊपर अपना जो आप टैप ऑफ वाटर के साथ एक अपना घर पे देखते हो, उसमें नोजल जो है वो हमारी रेजिस्टेंस एक्ट करता है, जो पाइप है वो एक्चुअली पोटेंशियल है और जिसके आगे जो उसके फ्लो ऑफ माउथ ऑफ द टैप होता है वो हमारे पास क्या है, इट्स अ अमाउंट ऑफ फ्लो ऑफ करंट. तो आपने उसको एक बेस लेकर आपने एक छोटा सा पैराग्राफ बनाकर मुझे उसको अपनी कॉपी पे लिख के रखना है एंड देन आई विल आस्क, यू विल सेंड इट टू मी. उसमें हमें बताना है कि आपने किस तरह इसको डेमोन्स्ट्रेट करके देखा अपने घर पे विद द टैप फ्लोइंग टैप ऑफ वाटर. दैट्स इट. थैंक यू सो मच क्लास.